people.
سجله. هيا شغال التسجيل.
Thank you.
Okay. So, tutorial. The first question says you have called a double word list with 4 elements. طيب انت when you come to this sort of questions لما احنا نحكي double word. اوكي لما نحكي double word how many bits? double word how many bits? 32. اوكي فهي اول معلومه جبناها. You have called a double word list of 4 elements. So the size of each element is 4 bytes. هي موجوده هون. Write an assembly program to find the results of the summation of the first 3 elements in this array and store the result as the last element in the array. فمثلا انا راح يكون عندي array عشان اعرف array of 4 bytes راح اسميها integer وراح نعطيها اسم نسميها sum. اوكي السايز تبعها 4 elements وراح نفترض فيها 3 values. الفاليو الاول راح افترض مثلا 0x 1 2 3 ارقام اي ارقام. اوكي 0x a31 0x 5a34 7 whatever والاخير 0 لانه I want to sum the first, second and third element and put the result into the last element. Okay طبعا I don't want to go and just say sum plus plus. I want to go through the memory. طيب so anything else in the question? The question okay ما في شيء. So what we have to do, we need to sum the values. In order to sum these values I will start by saying underscore ASM وافتح قوس. So size of the element I will define it as underscore integer أو بلاش we can just do it immediately. I will say move to cx4 لأنه هم 4. Remember I want to do a loop. بدي أقرأ الأول أجمعه مع الثاني مجموعهم أجمعه مع the sum of them I will add it to the third one والناتج I will put it in the fourth one. Move to cx4 بعدين I will say I will move sorry معلش then I will move to EAX. Why I'm using EAX لأنه 32 bits. Move to EAX sum معناته the first element of EAX of sum is stored in EAX. Then I even no need to do the loop. I can just write it since it does not say the loop. You can just do it immediately. It's very simple. Then move. Then add to EAX sum plus 4. Okay, so I'm now over here. تذكروا هدول are stored like this. If this is my memory, element الأول 2 3 4. These are for the first element. فعندك 0 1 2 3. The second element will be 1 2 3 4. Will be 4 5 6 7. The third element will be 1 2 3 4. This will be 8 9 10 or 11. And the fourth element will take the rest. فلما نحكي احنا plus 4 every time you add 4. بعدين add to EAX sum plus 8 and finally هيك جمعت حطيت الاول في الاي اي اكس، جمعت معاه الثاني، جمعت معاه الثالث. I added the third one. Then I will just simply say move EAX to, okay, move EAX to sum plus 12. This is the easiest way to write this program. تذكروا, if the program does not specify using loops, using jumps, this is easy. You need to sum three numbers. This exercise will focus only on how to move through the array. طيب لو كانت الارray, instead of that, my question was, instead of having a double word, it was word, so it's two elements. So in your program, instead of having here integer, you will have short. Instead of adding 4, you will be adding 2. So here 2, 6 and 8. 2, 4 and 6. 2, 4 and 6. Is this question clear? Okay. السؤال الثاني, you have 5 reading of 2 temperature sensors stored in 2 arrays called sensor 1 and sensor 2. Using assembly language code segment, use that would add each element of the array in sensor 1 to the corresponding element in sensor 2 and put the result in array total. The size of each element is 1 byte. The size of each element is 1 byte. So let's do this one together. I will do it on the emulator since it's 1 byte. So on the emulator, I hope that you can see my screen good. I will say origin 100 hexa. Then I will put dot data to define the data segment, and I will define my variables sensor 1 define byte. Okay, sensor 1 define byte. The question says each one of them contains 5 elements. Did I read 5 elements? أنا مش شايف. Is it 5 elements? 5 elements, yes. Sensor 1 define byte. I will give it 5 values. So let's give it 34 hexa, 51 hexa, 62 hexa, 3C hexa. هذول كم صاروا؟ 4. The fifth one I will give it 90 hexa. Sensor 2 also define byte. This is how we define the variables inside a sensor or inside the circuit. So sensor 2 define byte, let's call it 1A hexa, then sensor 2, then 1B hexa. I'm giving just arbitrary numbers, by the way. يعني ما حدا don't worry much about these numbers. I'm just giving arbitrary numbers to make things more clear. Okay. So then I will put dot. We forgot one more thing. We will define a result. We will call it sum. Define byte, and it has 5 zeros. 1, 2, 3, 4, and 5. Dot code. Now, what we want to do is we want to read the 43 and sum it to A1. then we want to move to the next one. So in order to do that, I will do a few things. First, I will use SI, move to SI. Remember, SI is a source index. Move to SI 0. Move to SI 0. Then I will load the effective address. Just give me 1 second to answer this call. Hello. Walaikum salam. Alhamdulillah. Okay, Asif, sorry for that. So what I'm going to do, I'm going to move through these using SI. So I will keep incrementing SI, and at the same time I need the address for the sensors. I can do, we can solve it in many ways. Let's try the first one. We will say move to AL sensor 1. Okay, move to AL sensor 1. This is going to move the 43 hexa into AL. Then طبعا sensor 1 plus SI. Then I will say move add لا الBL. okay, add لا الBL sensor 2 plus SI. okay, so I'm going to run this and make sure that this code is running fine. So this is fine. okay, remember when you write the code, it's good to check. So first of all, if I do single step, we'll check that it's still, yeah, if I do single step, you will see that the variables have been defined. If I go for variables over here, you can see that the variables are defined. Of course, I want to see 5 elements, so these are my 5 elements. okay, these are the 5 elements I defined over here. You can see them in the variables. So my code is over here, move to SI 0, so SI is zeros. Then move to AL sensor 1 plus SI. SI is equal to 0, sensor 1, so it will move hopefully 43. Move add sensor 2 اللي هو 1A plus BL. طبعا هاي خطأ. ليش؟ لأنه I need to add it with AL. So you can see the mistakes. This one is AL. Now I will say move to sum plus SI AL. خلينا نجرب. Now this is supposed to define the variables once more. Okay, so once more we define the variables. Then we move to SI to sensor to AL the first value, which is 43. Then we move sensor 2, we add sensor 2 اللي هي A1 مع القيمة اللي في مع ال 43, we add them, put the result into AL. بعدين I will move whatever is in AL into sum اللي هي هاي الارray, the first element. So you can see over here the first element is done. Okay, now the rest, instead of repeating all of this, so I am going to say over here increment SI, so SI will be 1. Over here I will put a label L1. Before the label I want to repeat this 5 times. CX is equal لا, move to CX 5. and then I will say loop L1. So the first thing I did was made sure that the first element is working fine, اللي هو adding this one plus this one put over here. بعدين since we are defining byte, so I need to move SI by 1. So increment SI. So SI for the next time will be 1. And at the same time, I made it do this thing 5 times. So I made CX equal to 5 and I looped the function through the label L1. I will run it once more and let's go through it one by one. So as you can see here, the variables, we moved to CX5. We moved to sensor 1 the value of SI, then we moved the result. I incremented SI, so SI now over here is equal to 1, as you can see. SI is equal to 1. Then we went back to the loop, move sensor 1 plus SI. Sensor 1 plus SI اللي هو we are supposed to move now 51. 51 will be in AL. Then we will add 51 plus 1B. It will be 6C. Okay, 6C. Then we will store the result into the next element. Then we will decrement CX once more. We will keep repeating this. Okay, the last one is going to be 0B اللي هي 90 plus 70. You can see here CX is equal to 1. And then I will put before loop, it will decrement CX. CX is equal to 0 and we will exit the program. Is it clear? يعني in these programs, before doing a loop, make sure that what's inside the loop is working for the first element. Then increment your SI, your BI, or your whatever value which is moving around and loop it. And then you are going to loop the value. So this is your answer for the second program. Alaikum assalam. Okay, now let's go for the. Is this one clear? Is this one clear?
Okay, do we always use S to move across the array?
Do we always use, sorry, what?
SI, source index.
شوفي, look, SI, source index, DI, destination index. These two registers, basically we use them for this purpose. Okay? We use them usually SI and DI. This is the common way of doing things. You can use other registers, yes, but it's basically using SI and DI. Okay?
So we can use DI also?
Yes, you can. Instead of using here SI, I can use DI, which is destination index, D, and D, and D, and I can emulate and it will work. I can also use base pointer, BP, I think, BP, right? Base pointer, BP, copy. I can use BP also, because these registers, they are general purpose registers and we can use them. You can use base pointer also without any problems. See here, you have DI, SI, base pointer. هذولا you can use them without any problem. Any other questions on this program? The idea is you need to keep your mind is how to move through the variables and how to do the operations and how to run the loops. Okay. Next one. Next one. The question says, program number 3, write an assembly program to store 3 integers 100, 67, and 91 in AL, BL, CL registers respectively, and find the minimum value among them using and store it in a variable called small. Type. I will put like this, and I will put like this, and let's start over. Okay, I will take this program copy. If you want to use it, let me put it for you over here on the Microsoft Teams. Okay, if anyone wants to try to run this program and go through it, you can use it. Control V. Okay, it's over here on Microsoft Teams. Let's go for the second program. The second program says what? The second program says سكرته كني. We have 3 values, so I will start again with origin 100 hexa. I need a variable called small, so I will say dot data small define byte, put 0 in it, then dot code. I will move what? I will move 100, move to AL 100. طبعا مش 100 هكسة لأنه 100 هكسة will not fit into AL. Move to AL 100, move to BL 67, move to CL 91. Now what they want us to do is to find the smallest between them. So in order to find the smallest, we will do the following. I will say compare AL with BL regardless of the values. Now if AL is greater than BL, if AL is greater than BL, then I will move. To give you an idea, you need to put your small value one place. I will assume that I want always my smallest value to be in AL. So compare AL with BL. Now jump. I will assume the first thing is AL is lower than BL. If AL is lower than BL, I will say jump if below to label L1. At label L1, I will come down here. At label L1, I'm going to do the following. This is label L1. At label L1, I'm going to say compare AL مع compare AL with CL. Also, I'm going to assume that AL is less than CL, and I will say jump if below to L2. في L2 okay, في L2 look what I'm doing. أنا عندي AL BL and CL. I compared AL with BL. You have 2 options. الأوبشن الأول إنه AL is less than BL. الأوبشن الثاني, the second option, إنه AL is greater than BL. So I took the first one here. If AL is less than BL, I said compare AL مع CL. Okay, compare AL مع CL. So I'm going to do a comparison between AL and CL. Maybe الرسمة مش ظابطة كتير, بس what I want to do is over here. Let me. Okay, if this was true, I will do a compare between AL and CL. اذا ال AL الحل الاول انه ال AL is less than CL، معناته ال AL اقل من ال BL وال AL اقل من ال CL. This means ال AL is the smallest value, so I will in small I will put AL. طيب نرجع هون. If AL was greater than BL, I will move whatever is in BL into AL. معناته ال AL صارت فيها القيمة الأقل and then I will go over here to compare AL with BL. وهنا إذا كانت ال AL أكبر من CL, so I will move whatever in CL into AL وبعدين I will put the result into small. ف when it comes to comparison between values, الأسهل إنه to compare two, and if the first one is smallest, okay, then it's fine. If not, move the small one into the variable where you want. يعني I assume that my lowest value I want it to be stored in AL. So over here in L2 I will say move to small AL, comma AL. Now نرجع هون. Here we said compare AL with BL. If AL was greater than BL, then I'm not going to jump and I'm going to execute move to AL BL. Then now I have AL having the lowest of AL and BL. Over here AL with BL, jump if below to L2. If AL is not less than BL than CL, then I'm going to say move to AL CL. This is what I did over here. دائما when you do the if statement, think in your mind you have two options. Okay, what if the option was true and what if the option was false? If the option was true, I jumped over here. If the option was false, I executed this instruction. If the option was true, I jumped over here. If the option was false, I'm going to execute this instruction. So if I emulate this one, see here our variables, we have small already defined. So move to AL 100, طبعا 64 64 because this is 100 decimal and this is in hexadecimal. If I double click over here, you can see it is in decimal 100. Okay. Now single step, move to BL 64 91. Compare AL with BL. Is AL less than BL? No. So am I going to jump? No. I'm going to execute move BL to AL. ليش؟ لأنه ال BL 67 the value will be moved into the value of AL. So AL will have the 67 اللي هي 43 hexadecimal. 67 اللي هي 43 hexadecimal. بعدين I will compare ال AL مع CL. What does compare mean? Compare means subtract AL with CL and check the flag. وين الفلاج؟ this is the flag. If AL is less than CL, معناته الساين flag will be 1, والcarry flag will be 1. So is AL less than CL? AL is containing 43, CL is containing 5B. So we do it. Sign flag, yes, AL is less than BL. So I'm going to jump. ليش؟ لأنه ال AL 67 وال CL 91. I'm going to jump if below the small, ده L2. So I'm going to jump over here. I'm going to move the value of AL into small, and small will have the value of 43 hexadecimal. Small will have the value of 43 hexadecimal. Okay? Any questions? Any questions? No questions? No questions is good, means everything is clear. طيب, let's go for the next one. You have 8 voltage signals stored in a memory location starting at this over here. Write an assembly program that stores the first 4 readings. in an array called voltage signal underscore 1, and the remaining 4 in an array called signal 2. Then find the maximum between each two corresponding values in the array and store the result in the same row in the third array called maximum. Note that the size of each element is 4 bytes. طيب ايش عندنا؟ سؤال it says وين راحت مش شايفها ليش. Okay. We have 8 voltage values. Okay, we have 8 voltage values. 1, 2, 3, 4, 5, 6, 7 and 8 voltage values. We need to store the first 4 هدول 4. We need to store them in an array called vol underscore signal. مش عارف من وين بجيب الاسماء. signal underscore 1, and we need to store the second 4 into vol underscore signal underscore 1 2 sorry. معناته هاي فيها 4 ارقام 1 2 3 4. This one will have 4 values also. Then we have a third array called max. We are going to compare this one and put the result over here. Compare this one with this one, put the result over here. Compare this one with this one, put the result over here. Compare this one with this one and put the result in the fourth value. Okay. تمام. Then you are going to write the program for this one. Write the assembly language code segment that finds the maximum value in the array called numbers and store the result variables. The maximum bits of each number is stored in 32 bits array. طيب, let's do this one. The last one I will leave it for you. Let's do this one. So what do we have? We know that the information is stored in a memory location 1329 hexa. So first of all, I'm going to do I'm going to say integer volume underscore signal underscore 1 4 values, integer volume underscore signal underscore 2 4 values. Then I'm going to say integer max 4 values and underscore ASM, and let's start the program. So in my program, first of all, I want to move the first 4 elements into signal 1. So quite simple, I will say move to CX4, move to SI 0, okay, and then move to volume underscore signal underscore 1 1 3 ايش كان الرقم 1 2 what was the number 1239 hexa 1239 hexa 1239 طبعا I'm going to say it like this 0x1239 plus SI. Okay, for this is the first element. Then I'm going to say add to SI4 semicolon. Then I'm going to say loop L1. Well, L1 يا جماعة I'm going to put it over here. Now I'm going to take the first element, put it over here. Then see, this is wrong. ليش؟ and I'm going to loop both. Plus si, okay, and over here I'm going to say 0x1239 plus si. ليش؟ because I want the first value to be stored in the first element, the second value to be stored in the second element, the third value to be stored in the third element. But this will cause a new problem for me. I will show you later on. So I'm going to loop this. Now, when it comes to the second array, si I will keep it. Now si is moving right, so I'm going to say move to di 0. ليش؟ because si I'm using it for something, I want di for something else. Move for di 0. Move volume underscore signal underscore 2 plus di. I will move to it 0x1239 plus si, because si is incremented. It moved already 4 values. I'm going to take to the 5th value, and then add to si 4, add to di 4, and then I will also over here I need to move to cx4 in order to loop once more، لأنه هون cx already 0. بس أوصل لهون، بس أطلع من اللوب. When I'm exiting the loop, cx is already 0. So I will reset cx as 0. Define di for the destination. Keep si as before. Keep incrementing si. Keep incrementing di and loop. L2. Now, this is the first part of the questions where I prepared the two values. The second part is similar to what we did in the first question, where I have two signal values and I want to find the maximum between them. So in order to do that, I will say once more move. I will change this one to another color because this is the second part. I will say move to si once more 0, and I will start the comparison. I will say move to EAX. Sorry, remember you cannot compare two memory locations, so you need to move to EAX volume underscore signal underscore 1 plus si. I will move it to EAX. Then I will say compare EAX with volume underscore signal underscore 2 plus si. This is the first comparing the first elements. If EAX is greater, jump if greater لا L3 في L3 I'm going to say move للماكس. احنا سميناه ماكس right. move للماكس EAX. sorry معلش wrong here. move للماكس plus si EAX. إذا it was not greater, then I will say move EAX الفاليو تبع volume underscore signal underscore 2 plus si. هذا الحكي needs to be repeated 4 times, so I say move to cx4. طبعا كلهم they need semicolons, بس it's not my thing now. si then I will say over here loop L4, and your L4 will be over here. Okay, this is the program. As you can see over here, what I did, the first part was to make sure that the two sensor readings are stored. Then what I did is just comparison between the same two. Again, you need to assume one of them is the largest, so I assumed always that EAX is the largest. If EAX, I moved whatever in the first value into EAX, compared it with the second. If it was greater, I moved EAX into maximum. If not, I moved whatever over here is into EAX and then moved it to maximum. Okay, any questions?
Yeah, in loop 2, why did you use destination index?
In loop 2, why I use destination index? Because I wanted the source index to remain. Look, as I moved over here, the destination index first was pointing here, then here, then here, then here. Now this is done where I moved these four. Now I want to continue without changing, because the first one with the first one, the second one with the second one, the third one with the third one, the fourth one with the fourth one. Now the fifth one, I want to store it in the first one over here, the sixth one over here, seventh one over here, eighth one over here. So I needed to use DI over here, while in the first loop SI was working for both at the same time. Did you get it? Because I had two loops. That's why I used the DI over here. See, DI, this is DI, DI over here. لأنه ال SI was already pointing in the first array. DI will be pointing over here. بس هنا I did not use DI لأنه they are the same. They are moving 0, 0, 1, 0, 0, 4, 8, and 12. Is it clear?
You told that SI you used for both.
If I used SI over here, if I used SI, SI is already over here pointing to 8. لأنه هون it started with 0, then 4, then 8, then 12. So SI is already 12, and after the last one it will be pointing to 16. So when it comes here, SI will be pointing to 16, 20, 24, and 28. Now while DI over here will be pointing to 0, 4, and 8, and 12. Over here SI will be pointing the same, 0, 4, 8, and 12. يعني I did not reset the value of SI. I could keep continuing using the values from here. Otherwise you cannot access these extra 4 elements at the end. Clear?
Yeah.
Any other questions? Okay, so I will leave the last question for you. The last question is basically write an assembly code segment that finds the maximum value in an array called numbers and store the result in variable. The maximum bits of each number is 32 bits. So you need to find the maximum in an array. You need to scan through that array and find the maximum of that array. Any questions? Any questions? Okay, then I will stop over here and I will upload this inshallah for you just after this class.